Any algebraic expression which contains two terms is called a binomial. Like x plus y is a binomial. Okay, 2x plus 3y. This is a binomial. Okay, so it contains two terms, 2x and 3y. So any expression that contains two terms is called a binomial. Similarly, the expression that contains three terms is called a trinomial. Okay, so and which contains more than three terms, they are called multinomials. Okay, so binomial theorem. In this binomial theorem, we are going to study how to expand higher powers of a binomial. For example, you know that x plus y whole square, or let's say a plus x whole square. Let me write it this way: a plus x whole square. You know the formula for a plus b whole square. It is a square plus 2ab plus b square. A plus x whole cube. You know the formula to be a cube plus thrice a square b plus thrice ab square plus b cube. Right? You know these two formulas: a plus b whole cube and a plus b whole square. Both the formulas you know. Now, what if I ask you to find the expansion for this a plus x whole to the power of 4? This is expansion that we don't know. Similarly, for higher power, if I want to expand a plus x to the power of 27, we don't know how to expand. The binomial theorem gives us a basis of expanding higher powers of binomial, like a plus x to the power of 27, a plus x to the power of 50, and so on. Okay, so what is the binomial theorem? The formal statement of the theorem is that if a and x are any two rational numbers and n is a positive integer, okay, remember n is a positive integer in this. Okay, we have a binomial theorem for negative and fractional index also, where n is a negative number or a fraction, but I think that has been excluded from the syllabus. Okay, but for the time being, we consider a plus x to the power of n, where say a and x are rational numbers and n is a positive integer. Under this situation, a plus x, according to the binomial theorem, you can expand a plus x to the power of n as nc0 e to the power of n x to the power of 0 plus nc1 e to the power of n minus 1 x to the power of 1 plus nc2 e to the power of n minus 2 x square plus nc3 e to the power of n minus 3 x cube, and so on. This will continue. Okay, this will continue till what? This will continue till, let me write the term in between. Any term here will be ncr e to the power of n minus r x to the power of r, and then this will further continue till ncn, till a, the power of a is reduced to 0 and the power of x is increased to n. So what you see here, this is your binomial theorem. What you see here is that we are starting with nc0, then nc1, nc2, ncr, and then we are going till ncn. This is for your the combination term. For the first term a, you are starting with the power n, highest power n, then we are reducing the power by 1 of a, then again we are reducing the power 1 of a, then again by 1, and then we continuously reduce the power of a until the power of a becomes 0 in the last term. Similarly, for x, for the second term, we start with the power 0 and next power is 1. We continuously increase the power of x by 1. Next term is x square. Next term is x cube. Next term is x to the power of r, any term. And finally, We stop until the x attains the highest power, which is your n here. Okay, so you have to remember this, that this the binomial theorem, for any power you can expand it, any power of a binomial you can expand it with the help of this rule. In fact, the binomial theorem can be proved very easily with the help of mathematical induction. Okay, the proof is not there in our syllabus, so I'll not discuss the proof. Okay, but but by mathematical induction we can prove the binomial theorem. Okay, so let us see how we can now expand the higher powers. Let us say I want to expand a plus x whole square by binomial theorem. Let us start with the lowest power. We know this expansion, yet let's see how to expand. So here n is 2. So first is 2c0 a square x to the power of 0. The next term is 2c1 a, reduce the power by 1, so the power of a becomes 1, and increase the power of x by 1, so it simply becomes x. And finally you have 2c2, and the power of a becomes 0, and the power of a increases to the highest power. So what you get here is 2c0 you know is 1, x to the power of 0 is 1, so you simply get an a square here, plus 2c1, nc1 the value is n, so 2c1 is simply 1, 2ax, and 2c2 ncn is also 1, e to the power of 0 is also 1, so you're getting x square. So now see whether we are getting this a plus b whole square formula. Yes, we are getting by binomial theorem. The important observation is here, important observation in this is that if you see that when the power is 2, how many terms are we getting? We are getting 3 terms. So when power of binomial is equal to 2, number of terms is equal to 3. Okay, or you can write this as 2 plus 1. Let us try a plus x whole cube, how to expand by binomial theorem. So first of all, we have 3c0 a cube x to the power of 0. Next 3c1 a square, and you increase the power by 1 of x. 3c2, you reduce the power of a by 1 again, increase the power of x by 1. And finally, we have 3c3, the power of a reduced to its minimum 0, and the power of a is x is at its maximum. So this now becomes 3c0 is 1, x to the power of 0 is 1. This simply becomes a cube. 3c1 is 3, a square x. 3c2 is the same as 3c1, which is 3, ax square. And 3c3 is 1, e to the power of 0 is 1. So this is, okay, this is my expansion of a plus x whole cube. Okay, so what you see again here is when power of binomial is, if you see the power of binomial is 3, how many terms are there? 1, 2, 3, and 4 terms. Number of terms in the expansion is equal to 4. Next, let us see how to expand a plus x to the power of, say, 6. How to expand this? We have 6c0 a to the power of 6 x to the power of 0, plus 6c1 a to the power of 5 x, plus 6c2 e to the power of 4 x square, plus 6c3 a cube x cube, plus 6c4 a square x to the power of 4, plus 6c5 a x to the power of 5, plus 6c6 e to the power of 0 x to the power of 6. Okay, so again what you see here is, if you find out the values of 6c0, 6c1, 6c2, you can get the actual expansion. But You can get the coefficients, in fact. Okay. And therefore, what you observe here is, again, important observation here is, when the power is 6, number of terms here is 7. If you count the number of terms, 1, 2, 3, 4, 5, 6, 7. The number of terms is 7, which is nothing but 6 plus 1. This leads to the conclusion that when the power, important note, when the power of a binomial, when the power of a binomial is n, then the number of terms in the expansion, is n plus 1. Any questions till this part?
No, sir.
So this is an important observation that we must make. So now we are going to start with some of the problems from binomial theorem based on these. Okay. Um, let's see. Let us see the first problem here. The first problem here is expand. This is number 4 that I'm doing here. Okay, expand 2 plus x to the power of 5 minus 2 minus x to the power of 5 in ascending powers, and simplify your result. Okay. The question is basically simplify this. Okay. So how will you simplify this? You will have to expand both of these by binomial theorem. This is a binomial and this too is a binomial. Okay. So you have to expand individually in terms of binomial theorem. So let us see the first one, how to expand. First is 5c0, 2 to the power of 5 x to the power of 0, plus 5c1, 2 to the power of 4 into x to the power of 1, plus 5c2, 2 to the power of 3 into x square, plus 5c3, 2 to the power of 4, 2 square, x cube, plus 5c4, 2 into x to the power of 4. And finally, the last term will be 5c5, 2 to the power of 0 into x to the power of 5. This is the expansion only for the first one, that is 2 plus x to the power of 5. Let's see about 2 minus x to the power of 5, what the expansion is. So you have 5c0, 2 to the power of 5, and see there is an x here, minus x here. So since we had a plus sign here, so we used a plus x here in all this. But whenever you see a minus sign in a binomial, you will work with the minus sign. So you can put a minus x to the power of 0, plus 5c1, 2 to the power of 4 into minus x to the power of 1, plus 5c2 into 2 cube into minus x to the power of 2, plus 5c3 2 square into minus x to the power of 3 plus 5c4 into 2 into minus x to the power of 4 plus 5c5 into 2 to the power of 0 into minus x to the power of 5. Okay, now let's see. Now we will simplify. Before, don't find the value of the combinations. We leave the combinations as they are. We'll see later what happens. 5c0 into 2 to the power of 5 you're getting for the first one, plus 5c1 2 to the power of 4x plus 5c2. We are simply opening the brackets. We're not simplifying at all. X square plus 5c3 2 square x cube plus 5c4 into 2 into x to the power of 4 plus 5c5 into x to the power of 5. 2 to the power of 0 is 1. Okay. Next, minus. Now you're opening the brackets at 5c0, or instead you can first simplify whatever is within, then you open the brackets. 5c0 is you write 5c0 as it is, and you write 2 to the power of 5, and you see minus x to the power of 0 is 1, so that is okay. This term does not contain any x. Next, see, I have a minus x here, right, and I have a plus sign here, so they combine to give you a minus sign. So this is minus 5c1 2 to the power of 4x. The next term is this one. See, I have a minus x raised to an even power, so this term becomes a plus. Minus x into minus x will give you a plus x square. So plus remains a plus sign here. So 5c3 2 cube and x square. Next, minus 5c3, and see, I have a minus x here raised to an odd power. So this will become a minus x cube. Okay, so this will become plus, from plus sign this will become minus 5c3 2 square into x cube. And again here you see a minus x to the power of 4 here, right? So this will become a plus x to the power of 4. So this plus sign will remain this into 2x to the power of 4, and you have a minus 5c5 is you write 5c5 as it is, to the power of 0 is 1, and since minus x to the power of 5, this is an odd power, so this becomes this plus sign becomes a minus, because this becomes minus x to the power of 5. So that's it. Now we shall open the brackets and see what terms cancel off. So 5c0, you can simply write this as 2 to the power of 5, because 5c0 you know is 1, plus 5c1, let's keep it as it is, 2 to the power of 4x plus 5c2 2 cube x square plus 5c3 2 square x cube plus 5c4 2x to the power of 4 plus 5c5 is again 1. In omit 5c5, simply write x to the power of 5 minus. Now we open the brackets. 5c0 is again 1, becomes 2 to the power of 5 simply. The minus again, then for the next term minus, since we open the bracket, this becomes a plus sign. 5c1 2 to the power of 4x. Again the plus sign becomes a minus sign. 5c3 2 cube x square. Again minus sign becomes a plus sign. 5c3 2 square x cube minus 5c4 2x to the power of 4, and then this again becomes a plus sign. 5c5 x to the power of 5. Okay, and in fact 5c5 also you can omit, because you know 5c5 is 1, so you simply write x to the power of 5. Now let's see what cancels. This 2 to the power of 5, this one cancels, this term also cancels. 5c1 2 to the power of 4. Now with the Here you have a 5c2 which cancels off again. This is a 5c2 here, not 3. So 5c2, this also cancels off. Okay, and what else cancels? Okay, this does not cancel. Sorry, this does not cancel. It's a plus sign. Okay, so both are plus signs. So this does not cancel. 2 to the power of 4 x remains. Okay, so this 5c2 term cancelled off. 5c3 terms remains. 5c4 term cancels off. Okay, and x to the power of 5 remains. So what are you left with? You are left with 5c1 twice of 5c1, 2 to the power of 4x. This one is left. 5c3 term is left, plus twice 5c3 2 square x cube. Okay, and I have a 2x to the power of 5. These three are the only terms that are left. Now we shall simplify to get our result. 5c1 is simply 5. 5 into 16x plus twice 5c3. 5c3 is the same as 5c2 into 4x cube plus 2x to the power of 5. And now what do we have? This is 160x plus twice of 5c2 can be written as 5 into 4 by factorial 2 into 4x cube plus 2x to the power of 5. Now let's see what I'll cancel. This 2 and this 2 will cancel off. You get 160x plus 5 into 4 20. 20 into 4 is 80. 80x cube plus 2x to the power of 5. That is the expansion. And if you want, you can take 2 out also. You have to find it and you have to write it in what? Ascending powers of x. Ascending means uh, from lower to higher. So this is twice of 80x plus 40x cube. Or in fact, you can take 2x common and then write it in ascending powers. Why only 2? You can take 2x common. So 2x I take common, I get 80 plus 40x square plus x to the power of 4. That's it. This is an ascending powers of x because see this, the powers of x continuously increase. Okay, so this is how you expand binomial theorem and you simplify. Okay, let us now do another problem, number 8 here. Number 8 here is expand 1 plus 2x. The question is one expand 1 plus 2x plus 3x square whole to the power of n in a series of ascending powers of x. Ascending means lower to higher. Up to and including the term x square. Okay, up to and including the term x square. Okay, x, we have to expand this in ascending powers of x. How will you do this expansion? If you want to carry out the expansion of this looks like a trinomial, but actually it can be brought down to a binomial. Now, how do you actually bring this down to a binomial? You take any two terms as up to and including the term x square. So you only have to expand up to the power of x, where the power of x is 2. So what you do here is, let us assume, let 1 plus 2x is equal to y. So therefore, what does this become? This becomes y plus 3x square whole to the power of n. Now this becomes a binomial. Now we can expand this, and till what we have to expand? you will have to expand only till the power of x is 2. Okay, only till the power of x is 2. So this is nc0 y to the power of n into 3x square to the power of 0 plus nc1 y to the power of n minus 1 3x square to the power of 1 plus nc2 y to the power of n minus 2 3x square square. Okay, plus nc3 y to the power of n minus 3 3x square cube, and so on. So we'll continue till ncn y to the power of n into 3x square to the power of 0. Uh, Sorry, not y to the power of n. This should be y to the power of 0, and this should be n. Y to the power of 0, and this should be n. Okay. Next, nc0 you know is 1. So y to the power of n and 3x squared to the power of 0 will be 1 plus nc1 is n y to the power of n minus 1 1 plus 2x to the power of n minus 1 into 3x square plus nc2 n into n minus 1 by factorial 2 into y to the power of n minus 2. 3 square x square means 9x to the power of 4, right? Plus now next term I will not write, because see I've already got a higher power of x. I've got x to the power of 4 here already, right? I have an x squared term here, so I'll keep this for the time being, and later I'll see if I can do something with this. But after this, whatever powers of x that I'm going to get, I'm going to get higher powers of x. And at the last, what you're going to get here is at the last what you're going to get here is ncn is 1, y to the power of 0 is 1. You're simply going to get 3x squared to the power of n. This is also a higher power of x. X squared to the power of n is a is much higher than x square. Okay, you have to only write till the powers of x square. Now you put back the value of y. What is the value of y? 1 plus 2x. So 1 plus 2x to the power of n, you write here, plus n into, in fact, this is 3nx square, 3nx square into 1 plus 2x to the power of n minus 1 plus, now next term I will not write because I don't need this term. They have only asked till the powers of highest power up to the power of x square, and this will continue. So I will not write the next terms. Okay, so I'll see next what happens. This is 1 plus x to the power of n here, 1 plus 2x to the power of n. Okay, now 1 plus 2x to the power of n, again if you expand binomially, you will get nc0 1 to the power of n into 2x to the power of 0 plus nc1 1 to the power of n minus 1 into 2x plus nc2 1 to the power of n minus 2 into 2x square. I will not write the next term because whatever power that I am going to get in the next term will be more than 2, right? And plus 3nx square. Here again, if I expand 1 plus 2x to the power of n minus 1 binomially, what will I get? First term will be nc0, 1 to the power of n minus 1 into 2x to the power of 0, plus nc1, 1 to the power of n minus 1 minus 1 means minus 2 into 2x to the power of 1, plus nc2, 1 to the power of n minus 2 minus 1, that means n minus 3 into 2x whole square. And the next term I will not write because this is again higher powers of x. Okay, so now let's see on simplification what happens. Now what's, if you see this first, this one, this is 1 into 1 into 2x to the power of the, this remains 1, plus nc1 you know is n into 2x, so this is okay. The power of x is 1 here. In the next term, nc2 is n into n minus 1 by factorial 2 by a formula for your ncr, right, into 4x square. 2x whole square is 4x square. That's it. I will keep it at this. I will not write the higher terms. For the next one, if you see, if you multiply 3 and x square, what is, how much this comes to? Just let me simplify. 3 and x square. nc0 is 1. 1 to the power of n minus 1 is 1. 2x to the power of 0 is 1. So that is remains. So it's only 1. Plus nc1 is 1. 1 to the power of n minus 2 is 1. So this is 2nx. Right? And the next term will be higher powers of x. Or you, if you want, you can write also. Let's see. We'll see in the next step that we'll actually get a higher power of x. So nc2 is n into n minus 1 by factorial 2 and 4x square. And this continue. Now what happens? If you see, this is 1 plus 2nx. So the power of x here is 1. So till this part is okay. Plus here, this cancels off with 4. It becomes 2n into n minus 1 x square. Okay. And this continues. Plus. Now what about this? If you multiply this with this, 3nx square with 1, you simply get a 3nx square. Right? And I will not write the next multiplication 3nx square into 2nx or 3nx square into this, because these are all going to give me x cube, x to the power of 4 and so on. So I'm not going to write the next higher powers. Okay, so the expansion of this up to the power of 2 will be 1 plus 2nx, plus from these two you can take your x square common to get 2n into n minus 1 plus 3n into x square, and after that will be your higher powers of x. So this will be, if you simplify this a little, 1 plus 2nx, you're going to get 2n square minus 2n, and minus 2n plus 3n will be, this is 2n square plus n x square. Okay. Further, you can write
Mm.
this as 1 plus 2nx, and you can take n common. You get n into 2n plus 1 x square. That is your expansion of this binomial. This is the expansion of this binomial only up to the powers of x, only up till the powers of uh, highest power, where the highest power of x is 2. Higher, the other higher powers I will not take, because in the question they asked only to write up to the x, where the power of x is 2. Okay, so that is what this is. Okay, and our class ends at what time?